Precalculus students, these are the second half of your 7.3 notes. We're going to focus on a brand new topic today called partial fractions. We've done a lot of things this year where you've just basically used things that you knew from the year before and maybe slightly changed them or did them the same, but today is actually something new. So buckle up and let's get ready to do some learning. So today, the decomposition of partial fractions, like I said, it's a brand new topic. It's one that actually shows up in calculus classes, so that's why we kind of introduce it here. We're going to keep it fairly simple, but essentially what it is, it's a way of rewriting a fraction. And maybe more precisely, it's a way of adding denominators together. As you can see in the example here, where we've been able to separate the denominator and break this fraction apart. Now that seems a little weird. We don't normally have that ability because x minus 3 times x plus 2 gives us this denominator. But by using partial fraction methodology, we're able to actually separate. So it's a new thing, but if you follow the patterns, you'll pick it up pretty quickly, I think. All right, so your first job, we're going to kind of walk through. I know there's a lot down here, but you'll sort of understand the patterns we're looking at. First thing you always have to look for is if the numerator has a degree that's larger than that of the denominator, or even if it's the same, to be honest. We would do long division and then just leave that first part of it out of it and actually only work with the remainder. Okay, so this is the part that we would work with, the 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. And that's where we would find the partial fraction. The x would still be part of the solution, but we would just put it to the side. All right, so the first step in the decomposition is to factor the denominator. And you can see we've done that on this example that you've got here. And then we break it apart. So a over x, that's one of the factors. B over x plus 1, that's another one of the factors. And it's a weird thing when you have repeated linear factors like x plus 1, you actually have to include not just the second degree version like you see on the original, but you also have to include the first degree. And if it was third degree, we'd also have to include a second, or if it was fourth, we'd have a first, second, third, and fourth all there. Now we're not going to get too crazy with these, so you don't need to panic. But if you do see a second degree, make sure you include both first and second. Okay, now this problem down here is a different problem, so don't worry that we haven't actually moved from here to here. It's just a different problem to show you another situation we deal with, and that is if we have quadratic factors like x squared minus 2, we have to treat those differently. But here's the reality. In this course, we're actually not going to study those, so I'm not going to spend too much time talking about it. But I just wanted to put it out there because some of you may see partial fractions in other places, and I want you to at least see this is a concept. It's not that hard. It's a little bit extra algebra. So we're going to do 4 problems together, and I think you're going to have a pretty good idea what's. So as we said on the previous slide, the first step to write a partial fraction decomposition is to actually factor the denominator. So I'm going to rewrite this as not just x plus 5 over x squared minus 4, but I'm going to go ahead and factor that denominator to be an x minus 2 and an x plus 2. Now, this is the step that's sort of new and sort of weird, but just follow along with me. Again, we have to break apart these two factors. So we're just going to put a term like an a, and the order of these is not important, so if you had factored in the opposite order, that wouldn't create any issues. Your A term and B term might have opposite results from mine, but it would still be totally fine. So we'd have A over x minus 2 plus B over x plus 2. So that's the first step. Just simply factor the denominator and then break it apart into multiple terms. All right, so what I want to do next is we need to focus on getting rid of the denominators for all of this big fraction we have here. So I'm going to multiply everything by x plus 2 and by x minus 2. So this is essentially just taking the least common multiple of the denominator, the least common denominator as we usually call it. And my equation now looks like this. X plus 5 equals a times x plus 2 plus b times x minus 2. So what I've done is, again, just multiply everything by x plus 2 and x minus 2 for the first term. That gets rid of the entire denominator. For the a over x minus 2, we still have an x plus 2 in the numerator. And for the b term, we still have an x minus 2 in the numerator. Okay, then the next step is to go ahead and actually distribute the a and the b. We'll work through this. So ax plus 2a plus bx minus 2b. Now I want to kind of pause for just a moment and talk about the concept we're going to use here. If I had a fraction, or an equation I should say, something like 3x minus 11, again this is not the one we have here, equals ax plus b. Okay, so if that was my equation I would start with, we would know, if you think about this in terms of, well, 3x minus 11 is just a line. The only way these two things can be true is if the slope of both these lines would be true. So I would know, would have to be the same, excuse me. So I would know a has to be 3 and b would have to be 11. So right there is sort of the concept we're going to use. Okay, this isn't obviously connected directly to this problem, but we've got to use that concept. It's one we haven't used a ton in our math, but it is there, and I think it makes sense if you think about it. All right, so I'm going to rewrite this a little bit. What I'm going to do is actually group the terms that have an x with each other. And a lot of you will realize we don't really have to reorder these, and a lot of you will probably choose to opt out of the reordering, and I'm totally fine with that. I'm with you. All right, so what I'm looking at is right here I have an a and a b that both have an x, and here I have an x. So I'm going to write a system that looks like this: a plus b equals 1. So all I've done is take the terms that I've underlined, ax plus bx equals x, and I'm just simply using coefficients. I'm not going to worry about rewriting the x's. They would all cancel out anyway, and we don't need them. All right. The next equation comes from the parts that I'm going to double underline here. This is anything that doesn't have an x. So I'd have a 2a minus 2b equal to 5. That's our system right there. Now that's a pretty simple system, to be honest. I'm going to skip some of the work on solving this system just to make this video, keep it from being too long. But when you finish solving this, and again, you can choose your method. I would probably use elimination, just to be honest. But I get a is 7/4 and b is negative 3/4. Okay, so the one job I have left to do is I need to plug those values back in. If I go back to where I started, how I broke apart the fraction, it's up here, a over x minus 2. So I'm going to rewrite that, but instead of a over x minus 2, it's going to be 7/4 over x minus 2, whoops, plus, and I know it's really minus, that's fine, but negative 3/4 over x plus 2. There's one more little step in this decomposition because we don't like having fractions over fractions. So we would want to go ahead, if we ran into this, we'd want to go ahead and factor out that 1/4 and rewrite this as 1/4 times 7 over x minus 2. And I'm going to go ahead and just write it as minus 3 over x plus 2. And that is our partial fraction decomposition. Now I know right now, especially since we ended up with fractions, some of you may wonder, like, well, what was the advantage there? And for right now, there's not a huge advantage. This is really a situation of trying to set you up for future classes. And so we can discuss that later. But for today and for this lesson, we're just stopping right here. Question 2 is pretty similar. In terms of having a quadratic term in the denominator that is factorable. So what I'm going to do again is factor the denominator. So I'll have x plus 5 times x minus 3 equals, and then we're going to break this apart, a over x plus 5 plus b over x minus 3. All right, so that's it right there. That is our the beginnings of our system. For now, it's just an equation. But in order to solve for A and solve for B, I need to get rid of those pesky denominators. So we're going to multiply by x plus 5 and by x minus 3. And that'll give us 3x plus 31 equals A times x minus 3 plus B times x plus 5. Now again, we need to distribute. 3x plus 31 equals ax minus 3a plus bx plus 5b. All right, so we have finished the distribution. Now what I'm going to do, I'm going to color code here instead of doing some of the grouping. I'm going to underline every term that has an x in it, and then I'm going to create an equation. Now it's 3 equals a plus b. I'm going to actually just write it as a plus b equals 3. And our other equation, we've got a 31, and then we've got a negative 3a and a positive 5b. So I'm going to write negative 3a plus 5b is equal to 31. That's our system. Okay. And again, I would use elimination. I'll go ahead and do the work this time. I'll multiply the first equation by 3. So 3a plus 3b equals 9. That means 8b is 40, and I've already found b then to be 5, and if I know a plus b is 5, or sorry, is 3, excuse me, and I know b is 5, then a would have to be negative 2. And so now we can go back to the original decomposition where we've split the fraction apart, and we're just going to sub in our values for a and b. So this is going to be negative 2 over x plus 5 plus 5 over x minus 3. Takes a little space to do all this work. There's a few steps involved, but it's really not that bad, right? I'm thinking that at this point you've kind of gotten the idea of these basic partial fraction decompositions. So why don't you do this, pause the video right now, and class, you work through this one, and in about 2 minutes we'll hit play on the video again and then see how you did. All right, I'm back, and you can see my work. Honestly, this problem was very similar. We just had to factor out an x. In some ways that actually made it easier. One thing I probably should point out, when you get to this step right here, 15x plus 63 equals a times x plus 7 plus bx, there's another method we can use where we can sort of skip solving the system in the traditional sense and use something called a heaviside cover-up method. I'll talk to you guys about it when I'm back. It's not a big deal, but it's just a different way to solve systems that it's kind of interesting. It shows up a lot on partial fraction decomposition where it can come in handy. So I'll show you that. Some of you may like it, some of you may hate it. It's fine. And if you use it, great. Just use it right. If you don't like it, again, no worries. All right, and so we end up with 9 over x plus 6 over x plus 7. Now again, the idea, just to make sure you're getting this, if we added those together, so we'd find a common denominator and then add together, we'd end up right back where we started, 15x plus 63 over x squared plus 7x. In calculus, this is much easier to work with, though. All right, we are already to our last problem. Again, I don't think there's anything too crazy on this one, but we do have an extra challenge. You might notice that the numerator is third degree, denominator is second. So right off the bat, we're going to have to do some long division. And what we're really looking for is the remainder, because the remainder is what we're going to work with for our partial fraction decomposition. All right, you guys know how to do the long division, so I'm not going to explain every single thing that I'm doing here, but I'm doing the steps that we've done before, nothing new here. So that would give me a negative 5x squared plus 22x minus 13, so then minus 5. So like I said, it's not like it's horribly challenging, but it is a little more tedious when you have to do this long division. Not going to lie to you. All right, so then 2x plus 2 is what we're left with. So I'm going to put this in red here, this 3x minus 5. We got to keep it in mind. It's not the answer, but we're going to keep that in mind. But really what we're dealing with is the remainder part of this, and then we're going to come back to the rest of it. So at this point, we're going to rewrite just the remainder portion of this, and I'm going to go ahead and factor it because we know x squared minus 4x plus 3 is x minus 3 times x plus 1, and that is where our partial fraction decomposition is going to happen. So again, division comes first. And as we've done on all the other problems, we're going to get rid of all the fractions. So we'll multiply by x minus 3 and x minus 1. And we'll end up with something similar to what we've seen on all the other problems. And again, I'm going to go ahead and distribute. And we'll set up our system. All right, so everything that has an x would be an a positive b, and that's it, and it equals 2. And everything that doesn't have an x is a negative a negative 3b, and it's equal to 2. So we've got our system right there. Now this one works out pretty nice for elimination, huh? So negative 2b equals 4. That means b is equal to negative 2, and if b is negative 2, a would have to be 4 for a plus b to equal 2, and we're ready to write our answer. But don't forget 3x minus 5. I put it in red so I wouldn't forget it. Here it is, 3x minus 5. Now we can write our partial fraction decomposition. So we're going to have our a term over x minus 3, and then our b term, which is negative 2, over x minus 1. All right, folks, I think you're seeing some patterns. I hope that this sort of makes sense. It really is kind of an introductory course to partial fractions, but it's kind of a cool concept. It gives us a little free practice on solving systems, on long division, and a few other little topics here and there. So do your best, work hard, and we will see you soon.